Next, our problem consists of a scenario analysis of what happens to that bookstore. We right now said that our demand is 2,000 and our order that we take in is 2,500. Now, the next part of our problem shows that what we really expect the demand to be, the demand can actually vary from even 500 to 4,500, and we have assessed a few probabilities here. I'm just going to turn it into percentages for a second. I'm going to select these probabilities, say right-click format cells, or right-click format cells, or even better, Control 1. And here it is. Let's turn it into a percentage, and we see that with a 2.5% probability, our demand is only 500, or 5% says that it's 1,000. And let's say 15% says that it's 3,000, and so forth. So that's how we assess our probabilities to be. I'm going to turn those back into numbers. So 2.5% is 0.025. Okay, so here we are. Now let's write out those demand numbers. We can even copy it. So right-click copy, and let's put them up here. So these are the demand numbers. And let's put them on the right side as well. It's 500, 1,000. Now select these two, copy them together up to 4,500. So what we're going to do next is we are going to make a two-dimensional data table. So a data table which will have here next to each other the demand numbers, and here below each other the order quantities, the demand numbers. And we can do such a table. So these are the demands, these are the order quantities, and what we want to see is the result is equal and profit. So we want to see the profit, and what we need to do now is select the table, say data what if analysis data table. We've been there in the previous exercise, data what if analysis data table, and select as column input cell, so the things that are below each other in a column. These are our order quantities, as said before. Row input cell, things that are next to each other in a row. These are demands. So we're playing around with both of them, and we are always calculating the profit. So for instance, this number here means that if demand is 1,000 and we've ordered in 2,500, we'll have a nice loss at our hand, minus 10,000. Or if really demand is 4,500 and we've ordered in just as much, 4,500, we will have a huge profit, $39,000. So it's all about catching what the demand really is going to be. But we don't know, because we only know what the probabilities for the demand will be. Of course, if we look at this row, let's say we will look at the first row. When we buy in 500 and look at the different demands, then since we've been buying in 500, we will always get this profit of 3,000 because at least 500 we can always sell. The demand is at least 500, but we won't get more as well, because the purchase we've made is only 500. So kind of a safe way to go. Let's look at purchasing quantity 1,000. If the demand is only 500, we will be nicely in the losses. And then the bigger demand means that we will be able to sell our 1,000 and always get 7,000. Let's take another. For instance, let's take the order quantity 2,000. We've ordered 2,000. If the demand is so little, we're in minuses. If the demand is bigger, we're in less minuses. And already from 1,500 with the order quantity 2,000, we're already in the profits, and we'll get bigger profits still. Okay, so what we want to do next is we want to go and write down order quantity 500, and now it turns out to be is that we can calculate what is called an expected average profit, or expected profit is the term. So if the order quantity is 500, then what we can do is we can multiply together one by one these values here. So if let us write this at first like this. If demand, if order quantity is 500, then 2.5% says that we will get 3,000 of profit. Plus another 5% says, and now I'm taking the next profit. It just happens to be the same in this row. Okay, perhaps it would be better to show it with another number. Let's say this 1,000 is here in the middle. This is the order quantity, and we're dealing with 1,500 as the order quantity. So what do we expect the profit to be? With 2.5%, we expect it to be minus 9,500. Plus, with 5%, we expect it to be plus 500. With 15%, we expect it to be 10,500. And so forth. With 25%, we expect it to be 10,500. With 25%, we expect it to be 10,500. And so forth. So what we're doing is we are multiplying these together. And what we get is, for all the probabilities, all the profits we'll have, we'll enter it, and here it is. We can say that if we make the order size to be 1,500, then as we multiply together all the profits with a different demand size, we multiply these together with the probabilities of that demand size, we get the kind of average or expected profit for this case. So once again, our order is 1,500. These are the different profits associated with this order size. If we multiply together with those probabilities, what we get is the expected profit, or the average profit that will come in. Okay. Now it turns out that this formula, we don't have to do this formula like this. There is a function for such multiplying and adding together. There is a function for such multiplying and adding together. And this function is called sum of products, sum product. And what we need to do, we take these probabilities, 2.5%, 5%, and so forth, and semicolon, and we're going to take these profits in case demand is 1,500. We're going to take these profits. And it does exactly the same thing. The result is 9,500. Now let us finish by writing together here 2,000 and copying these until 4,500. Actually we can copy this sum product as well. Because think of it. This probability's name is actually going to be fixed. And this will be moving up and down. So if we copy this formula up and then down, what we get is that we are just picking a different order size and multiplying together the probabilities and the profits for this order size. So that's how it goes. So what interests us is to know which order will have on the average, the highest expected profit. So that's why we have been doing all these calculations. We want to know which order to place so that our expected profit on the average will be the highest. So here it is. The order 2000 will have with it 12,250. So we can first put a graph on the display. So we choose those points, and just as in the previous example, these are like things on the x-axis and these are the y-axis values. So when we choose them together, we can use insert and scatter graph. And just to choose a better, sorry, this could also be, we haven't looked at column graph so far. So column graph will just simply show us the different profits, expected profits in a finer way. And now, just to finish it up, we're going to write equals max, and we're going to take the biggest expected profit, which is this 12,250, and then we're going to take and check for this 2,000, how to find that automatically. Where, at which order is what we're finding out. And for that, we actually can use again index and match. We have to know on which row here is 12,000 on 4, okay? And then go to the other block and take the fourth value out, and we get this 2,000, which is the corresponding order quantity. Okay, we write equals match parenthesis begin, and we take this block here. Sorry, at first what we're searching for, 12,000 from this block. And now, since these values are here exactly, there is no like up here we had to search for book cost. So that our order 2,500 was not exactly present at this other table. Here, these are present exactly, so we write semicolon 0. Other case had semicolon 1. Okay, and the result is fourth row, just as we expected it to be. Okay, and now let's use index, equals index, and we're taking from the order quantities, we're taking the fourth row out. So once again, match will give us row number 4, and it will entirely be replaced with number 4. And then index will take from this blue block the fourth one, which is 2,000, and here we have it. The final result. The highest expected profit is 12,250, and it's at the order size of 2,000. So that's why we used all these probabilities here. We got our optimum decision, so we should place actually an order of 2,000.